They called it the world's first true engine factory, and with good reason. In 1864, Nikolaus Otto, a traveling salesman with an obsession for technology, teamed up with engineer and financier Eugen Langen in Cologne to create machines that could finally make combustion practical. That modest workshop would grow into Deutz AG, a company whose engines went on to transform agriculture, transport, and industry far beyond what either founder could have imagined. The starting years. In his beginning years, Otto was always on the move, but his heart belonged to machines. In 1860, he discovered a new invention from Frenchman Etienne Lenoir, a coal gas engine. The design was bulky, inefficient, and painfully impractical. Yet to Otto, it was proof that combustion could work. His vision went further. He wanted to build a machine that, in his own words, could be easily and practically used for the locomotive of vehicles on country roads, as well as being of considerable benefit to light industry. That bold statement would later become famous because it was exactly what he wrote in his 1861 patent application to the Royal Prussian Ministry of Trade. The design, which relied on a spirit carburetor, was rejected. But rejection didn't end his mission. It redirected him. Otto partnered with Cologne mechanic Michael Zahns to replicate Lenoir's design, then quickly moved to his own experiments with compressed gas-air mixtures. He even tested a four-stroke concept that combined induction, compression, combustion, and exhaust in a single cycle. The theory was brilliant, but the lack of controlled ignition caused violent explosions that destroyed the engine after only brief operation. By 1863, Otto found more stability with what he called his first atmospheric gas engine. Primitive, yes, but workable. It proved he was onto something. The problem was money. He was broke, and his experiments were about to collapse for good. Fate intervened in the form of Eugen Langen, a Cologne-based engineer and businessman from the sugar industry. Langen wasn't dazzled by polished machines. He was impressed by Otto's persistence and raw ideas. He believed they deserved funding, and he had the means to provide it. In 1864, Otto and Langen officially founded N.A. Otto & C. Otto brought the technical brilliance. Langen supplied the capital and business connections. Together, they established what would become recognized as the world's first dedicated engine factory, laying the foundation for internal combustion history. Otto and Langen atmospheric gas engine. 3 relentless years of trial and error finally paid off. In 1867, at the International Exposition in Paris, Otto and Langen unveiled the atmospheric gas engine, a modest half-horsepower, single-cylinder design that didn't look like much, but promised something very different. At first glance, it didn't seem revolutionary, but during the demonstrations, it stunned the audience. The Otto Langen consumed roughly half the gas of competing engines for the same power output. In an era when fuel costs made or broke machinery, that kind of efficiency was a game changer. The judges took note. The little Cologne-built engine won the exposition's grand prize, giving Otto and Langen the international recognition they needed. Their tiny workshop was no longer just surviving. It was competing with the world. What made this engine special? The genius of the Otto Langen wasn't about brute horsepower. It was about how cleverly it was built. At its heart was a vertical cylinder with a free piston that moved under the pull of combustion gases and atmospheric pressure. A flywheel and pulley on the main shaft carried the output, while a carefully geared accessory system slowed the motion to reduce stress and keep the drive smooth. To manage speed, a flyball governor controlled the exhaust valve. If the engine slowed down, the governor allowed the piston to fall further, resetting the cycle automatically. Ignition was a simple but ingenious trick. Every firing blew out the tiny internal flame, so the slide valve briefly lined up with an external flame to relight the charge for the next stroke. Fuel was supplied by illuminating gas at very low pressure, supported by an accumulator bag that stored surplus between strokes to keep the cycle steady. Cooling came from a water jacket that relied on natural circulation, while lubrication was kept simple and manual. Operators could oil moving parts while the machine was running, keeping it in service without downtime. All of these details added up to something rare for the era, an engine that was efficient, quick to start, and reliable under continuous load. In workshops that needed practicality as much as innovation, that combination made all the difference. Bankruptcy and the Otto cycle. But early success could not hide financial reality. The costs of building engines at scale dragged N.A. Otto and CIA into bankruptcy. The collapse might have ended the story altogether, but Eugen Langen stepped in once again. He raised new capital, relocated the business to Deutz near Cologne, and restructured it as Gasmotoren Fabrik Deutz. That company would later evolve into Kluckner Humboldt Deutz, and eventually into the Deutz AG we know today. Langen also made two crucial hires, Gottlieb Daimler and Wilhelm Maybach. Their task was to bring discipline to production and buy Otto enough time to pursue his dream, a robust four-stroke engine. 14 years of persistence finally paid off. In 1876, Otto unveiled his compressed charge four-stroke design, the engine that would become known worldwide as the Otto cycle. With four strokes across two revolutions, induction, compression, combustion, exhaust, it became the blueprint for nearly every gasoline engine that followed. But success also created conflict. Otto and Daimler clashed over patents and priorities, and the disputes grew personal. Daimler and Maybach eventually left, taking Otto's four-stroke principle and pushing it to higher operating speeds, up to 650 revolutions per minute. That breakthrough made their versions ideal for vehicles, boats, and eventually carriages. By the 1880s and 1890s, Daimler and Maybach engines were powering some of the first motorized transport in history. Otto, meanwhile, faced his own challenges. His engines were tied to the public gas network, limiting where they could be used. That changed in 1884, when he introduced low-voltage magneto-ignition. This allowed engines to run on liquid fuels for the first time, opening entirely new applications. The system would later be developed further by Robert Bosch, becoming an industry standard for decades. Tragically, Otto didn't live long enough to see just how far his designs would carry. He died in 1891 at the age of 59, leaving behind the cycle that still defines modern engines, and a company that was now strong enough to carry on without him. Deutz's progress post. Otto's death in 1891 did not slow the company he founded. Deutz pressed forward with technical progress, and by 1892, it was already building locomotives powered by internal combustion. Just 4 years later, in 1896, it rolled out the world's first mining locomotive, a machine rugged enough to handle the brutal conditions underground. Shortly after, Deutz unveiled its first in-house diesel engine, a milestone in engineering. Sadly, Eugen Langen had passed away a year earlier, in 1895, and never witnessed this achievement. The turn of the century brought a new era. In 1907, Deutz began mass-producing diesel engines, opening markets that ranged from industry to transport and energy generation. Years of steady development had put the company in a strong financial position, and now diesel power promised to take it even further. But why were these engines so transformative? The answer lies in Rudolf Diesel's breakthrough theory of compression ignition. Unlike gasoline engines, which needed a spark, diesel engines relied on heat and pressure to ignite fuel injected directly into compressed air. This allowed them to run with compression ratios of 14:1 to 25:1, far higher than gasoline designs, and the payoff was greater thermal efficiency and much stronger torque. By the early 20th century, Deutz was already producing self-igniting engines capable of 400 horsepower, powering everything from energy plants and pumping stations to ships and transport equipment. Then came a leap that redefined practicality. In 1911, Deutz introduced the world's first compressorless diesel engine in series production. Up until that point, diesels required bulky, complex compressors to push fuel into the cylinders. They worked, but they were heavy, costly, and impractical for broad adoption. Deutz stripped away that complexity. Without compressors, the engines were smaller, more reliable, and easier to maintain. Suddenly, diesel power became accessible to far more industries, from transport to everyday machinery. This compressorless design laid the foundation for the modern diesel engine and cemented Deutz's status as a pioneer. Revolutionizing diesel technology. The 1920s brought another decisive advance. In 1921, Deutz launched the VM series, short for Viertakt motor, or four-stroke engine. These diesels introduced airless direct fuel injection, sending fuel straight into the combustion chamber without compressors. It was a simpler, cleaner, and more economical design that quickly became a benchmark. Performance figures told the story. The VM series achieved a specific fuel consumption of just 168 grams per horsepower per hour, a number so efficient it still stands out a century later. Then, in 1924, Deutz pushed further with the pre-combustion chamber process. This allowed smoother combustion and higher operating speeds, making diesel power a practical choice, not only for stationary applications, but also for vehicles and heavy machinery. These breakthroughs didn't just improve efficiency, they broadened diesel's potential. For industries where durability and performance were non-negotiable, Deutz had turned diesel from an experimental technology into a dependable workhorse. Transforming agricultural engineering. By the mid-1920s, Deutz was no longer just perfecting engines for factories or locomotives, it was reshaping agriculture. At the start of the century, most farmers still relied on horse-drawn plows, and in some regions, bulky steam tractors that were expensive, slow, and hard to maintain. The world was ready to move beyond 1 horsepower, and Deutz was ready to supply the alternative. In 1926, the company introduced the MTH222, its first diesel tractor to go into series production. On paper, it looked modest. A single-cylinder, 4-stroke diesel laid horizontally, producing about 14 horsepower. It came with a basic frame construction, a 2-speed gearbox, a chain drive, and evaporative cooling. But in the field, it was transformative. For the first time, farmers had a machine that could plow all day, handle heavy soil, and do it more efficiently than teams of horses ever could. The tractor's success set Deutz on a clear path. In 1929, it launched the MTZ series, beginning with the 30 horsepower 220 model. This tractor proved so capable that within 2 years, it won a silver medal from the German Agricultural Society. By 1936, over 2,000 units of the MTZ 320 had been sold, solidifying Deutz's reputation in agricultural machinery. Farmers across Europe now had a dependable diesel partner in the fields, one that made productivity less about muscle and more about mechanical efficiency. During World War II, Deutz's development shifted heavily toward military production, with its engines powering vehicles, generators, and equipment for the German war effort. Civilian innovation slowed, but in the aftermath, Deutz made a move that would define its identity for decades: the introduction of air-cooled diesel engines. In 1949, it launched the F1L 514 and F2L 514, compact and rugged engines designed to run anywhere, under any conditions. The naming told the story. F for Viertakt, 4-stroke, the number for cylinders, L for Luftgekühlt, air-cooled, and 514 for the engine series. The F1L514 was a single-cylinder design producing about 11 to 12 horsepower, while the 2-cylinder F2L514 doubled the output. But the numbers were only half the story. These engines eliminated radiators, pumps, and coolant systems altogether. Instead, they used deeply finned heads and barrels to shed heat into the air, with a fan ensuring consistent airflow even under heavy loads. The simplicity meant there were fewer parts to fail, making them cheaper to build, easier to maintain, and far more reliable. The 514 engines were also built for endurance. They ran at low RPMs, used simple mechanical fuel injection, and tolerated poor quality fuels, making them nearly indestructible in daily service. Mounted in tractors like the Deutz D15 and D25, they became staples of post-war European farming, modernizing agriculture at a time when food production was critical to rebuilding. But their reach went far beyond the farm. Air-cooled Deutz engines powered construction equipment, stationary machinery, and generators. Export markets embraced them, especially in Africa, the Middle East, and Latin America, where extreme heat and limited maintenance support made liquid-cooled engines unreliable. In these conditions, Deutz's air-cooled diesels thrived, running where others failed. By the 1950s, the 514 series had cemented Deutz's global reputation as the builder of engines that could take punishment and keep working. Over the next 2 decades, Deutz would scale this concept into larger, more powerful families that carried it into the modern diesel age. 812, 912, and 913 series. By the mid-1950s, Deutz was ready to scale its proven air-cooled concept beyond the compact 514. In 1955, the company launched the 812 series, the first step toward heavier-duty applications. These engines carried the same DNA of rugged simplicity, but were re-engineered for bigger loads and longer duty cycles. Stronger crankcases, improved heat dissipation, and an enclosed fan-driven cooling system gave them the muscle to handle industrial-scale work. The 812 family came in 2 to 6 cylinder inline versions, producing between 30 and 120 horsepower. They relied on direct mechanical fuel injection, robust bearings, and low-speed operation in the 1,500 to 2,200 RPM range. The combination meant they could run hard, day after day, with the kind of dependability that industries demanded. Then came the real leap forward. In 1965, Deutz introduced the 912 series, an engine family that would set a new global benchmark. The breakthrough was modularity. By standardizing parts across 2, 3, 4, and 6 cylinder versions, Deutz made both production and servicing easier, a huge advantage in industries where downtime meant lost revenue. The 912 also brought better airflow systems that improved cooling efficiency while cutting noise. Precision-timed fuel injection pumps delivered more consistent combustion, making the engines both cleaner and more reliable. With outputs ranging from 30 to 150 horsepower and operating speeds between 1,800 and 2,500 RPM, the 912 quickly became the engine of choice for tractors, construction machinery, generators, and trucks. It built a reputation for thriving anywhere, from freezing winters to desert heat, with minimal maintenance. By the 1970s, Deutz pushed the concept further with the 913 series. It was a direct evolution of the 912, but with refinements in airflow, stronger blocks, and reinforced cooling fins to withstand higher thermal and mechanical stresses. Most importantly, the 913 introduced turbocharged versions. These boost power without sacrificing the simplicity and ruggedness of air cooling. Combined with an efficient fuel injection and combustion system, the 913 delivered strong performance while keeping fuel consumption low. Together, the 812, 912, and 913 families carried Deutz firmly into the modern diesel era. They proved that air-cooled engines weren't just a quirky alternative. They could be scaled, refined, and pushed to perform at levels competitive with liquid-cooled designs, all while keeping their trademark durability. By the time the 913 was in full swing, Deutz was ready for its next challenge: compact oil-cooled and liquid-cooled engines for a new regulatory and industrial landscape. The 1011, 1012, and 1013 series. By the 1980s, the diesel industry was shifting under new pressures. Tighter emissions regulations, smaller equipment designs, and stricter efficiency demands meant that engines had to do more in less space. Deutz, long known for its air-cooled workhorses, adapted quickly. The result was the 1011 series, a compact line of oil-cooled diesels that marked a new direction for the company. The 1011 engines used circulating oil and integrated fans to manage heat, a clever solution that reduced overall engine size and weight while still delivering reliable power. Designed primarily for smaller construction machinery and compressors, they packed surprising performance into a small footprint, exactly what equipment makers needed as space constraints and efficiency targets grew tighter. Deutz didn't stop there. Building on the 1011's success, the company introduced the 1012 and 1013 series. This time, Deutz made a decisive move into liquid cooling, a shift that aligned with new global emission standards while preserving the company's hard-earned reputation for durability. Offered in 4 and 6-cylinder versions, the 1012 and 1013 engines covered a wide 50 to 250 horsepower range, making them versatile enough for everything from agricultural equipment to heavy construction machinery. Among them, the 1013 stood out. It became a global favorite thanks to its blend of fuel efficiency, reduced emissions, and modular design. Operators valued it not just for power, but for the way it fits seamlessly into modern machines while maintaining the rugged reliability that defined Deutz. By the mid-2000s, the lessons of the 1011, 1012, and 1013 had positioned Deutz perfectly for the next leap forward. The company was ready to launch a new wave of engines that would carry it into the 21st century, combining modern compliance with the toughness that had always been its hallmark. 2011, 2012, and 2013 series. As the new century approached, Deutz built on decades of innovation with a fresh wave of compact engines. The first was the 2011 series, introduced as the natural successor to the 1011 line. It kept the company's signature oil-cooled approach, but improved it in every way. These engines remained light and compact, producing up to 75 horsepower, which made them perfect for small and medium-scale industrial equipment, where space and weight were critical. The 2011 quickly earned a reputation for toughness and versatility, but one feature stood out above the rest: its excellent cold starting performance. In markets where machinery had to work through freezing winters or unpredictable climates, the 2011 gave operators confidence that their equipment would fire up and keep running. That reliability helped Deutz strengthen its global reach, from established European industries to developing markets where durability mattered most. The next step came with the 2012 and 2013 series, and here the company made a bigger leap. These engines abandoned oil cooling altogether and transitioned fully to liquid cooling, with coolant circulating through the block and releasing heat through a radiator. It was a shift that aligned perfectly with international emission standards and rising expectations for fuel economy. More importantly, the 2012 and 2013 models introduced high-pressure fuel injection, which meant cleaner combustion, better fuel efficiency, and reduced emissions. With these upgrades, Deutz engines weren't just more powerful and efficient, they were also Tier 3 and Tier 4 ready, meeting the strict regulations set in both the US and Europe. The result was two engine families that became trusted choices across agricultural, industrial, and construction markets. They proved that Deutz could modernize its technology while holding on to the rugged, reliable character that had built its name. And with the 2013 series, the company had laid the foundation for the modern TCD and TCG families that define Deutz today. TCD and TCG series, modern-day engines. Today, the heart of Deutz's lineup is the TCD family, a showcase of how far diesel technology has come since Otto's early experiments in Cologne. TCD stands for Turbocharged Common Rail Diesel, and it represents the company's modern standard for efficiency, durability, and performance. The lineup spans models from 2.9 to 7.8 liters, covering outputs from roughly 30 to over 400 horsepower. At the core of each design is common rail fuel injection, paired with advanced electronic engine management. These systems allow precise control over combustion, giving TCD engines the combination of high torque, quick throttle response, and low emissions that industries now demand. Whether powering construction machinery, agricultural equipment, or industrial plants, the TCD series delivers the balance of power and efficiency that has become Deutz's hallmark. Alongside the diesels is the TCG series, a clear signal of where Deutz sees the future. TCG stands for turnkey combustion gas, and these engines are built to run on gaseous fuels like natural gas, biogas, or even landfill gas. By doing so, they offer customers a cleaner combustion profile, which makes them especially valuable in applications like power generation, agriculture, and industrial operations, where emissions and sustainability targets are front of mind, and Deutz is not stopping there. Building on these same foundations, the company has moved into hybrid-ready platforms and even hydrogen-powered designs, such as the TCG 7.8 H2. These engines show that Deutz isn't just keeping up with change, it is actively shaping it, combining over 160 years of engine building experience with the fuels and technologies that will define the next century. From Otto's atmospheric gas engine in 1864 to hydrogen-ready models today, Deutz has carried its legacy through adaptation. The company that gave the world the four-stroke cycle remains the oldest surviving engine manufacturer, and its products have powered farms, factories, ships, and construction sites across the globe. More than 160 years later, the story of Deutz is still being written, one engine at a time.